I am Prabhakar. We will be discussing motion of objects in one dimension. That is, man has been fascinated by movement of objects, whether it is of planets in the sky or birds in sky or fishes in water or any vehicle which is man-made. To understand the motion of objects, we will begin with motion of objects moving in a straight path. Consider point O, which is a reference, and I am trying to indicate a straight path along this line. Now, anything that moves in here changes its position. Let us say the position is at x at time t. Now, when we say the object is moving, what we mean actually is its location with reference to a certain point which I have indicated here as origin varies with time. That is, position, variation of position with respect to time is generally called as motion. In one dimension, x should vary with time. Consider, for example, a situation like this, which I am going to present. This is variation of position with time. T is given in seconds, x is given in meters. Say, for example, at t is equal to 0, it is at position 10 meters from the origin. T is equal to 1 second, it is at a position of 15 meters. Like this it goes on. Now, if you look at this data, x is continually changing with respect to time. We say, let us analyze this motion. Now, to look at this, I will plot the variation of position with respect to time, which I call it as position time graph. Look at the variation of position with respect to time of the data that I gave. Now, t is equal to 0 seconds, the position of the object is 10 meters. At t is equal to 1, it is at 15. At t is equal to 2, this is the kind of a plot that I have done, and it has been done from time t is equal to 0 to time t is equal to 11 seconds. Look at this graph carefully. What do you observe in this graph? The position variation with respect to time is what is indicated. Now, at t is equal to 6 seconds, the position is 28. Till 0 to 6 seconds, the position goes on increasing. Afterwards, what is happening? The position is decreasing. What does it mean? It means if you look at the x coordinate, it is moving along a straight line and it is coming back towards the origin. That is all it means. See, at t is equal to 7 seconds, it is at 27.5 meters, whereas at t is equal to 10 seconds, it is at 17 meters. It means it is going along a straight line till t is equal to 6 seconds, then started moving backwards. That is, x goes on decreasing with t after it has reached the maximum position. Now, this variation of position with respect to time is measured in terms of a quantity which we define as average velocity. What is average velocity? Look at this graph again. The position of the object goes on changing with time. It starts from t is equal to 0. At t is equal to 0, it is at 10 meters, increases its position from the origin up to t is equal to 6 seconds. Then it starts moving backwards along the line, in the same line, till say at t is equal to 10 seconds, it comes to a certain other position, which is lesser than what it started with. Now, I told you we will define a quantity called average velocity. Average velocity is defined as V average as the change in position. Say, for example, it is at position x2 at time t2 and it is at position x1 at time t1, then we define a quantity called x2 minus x1 divided by t2 minus t1, which we call it as average velocity. Let us look at some portion of the graph which I am indicating here. At time t1 the position coordinate is x1, at time t2 the position coordinate is x2. The positions are indicated as p and q here in this graph. Now, it means the position has changed from time t1 to t2 in the time t1 in the interval time from t1 to t2, the position has changed from x1 to x2. If I join this point p and q by a straight line pq and then draw a line parallel to the time axis, which is indicated here as PR, QR gives you change in displacement in the interval t2 minus t1. The slope of this line PQ is defined as QR by PR. Here it is x2 minus x1 divided by t2 minus t1. We call this as the slope of this line PQ, which is joining the points P and Q along the curve. Now, in terms of the graph, what we mean by average velocity is delta x by delta t, which is nothing but the slope of the graph. So, slope of position time graph gives you what we call as the average velocity between the points P and Q or between the interval time t2 and t1. So, delta x, which is the change in position coordinate, divided by the time interval, for this we define it as average velocity. Having defined average velocity as delta x2 minus x1 by t2 minus t1, which can also be written as change in position coordinate delta x, change in time coordinate, which is delta t. Let us try to calculate how is this average velocity is changing at different time intervals. Let us take, for example, let us put time t1 as 0 seconds. At time t1 0 seconds, the position coordinate corresponding to it is 10 meters. At time an interval of say 2 seconds, at time t2, which is 2 seconds, the position coordinate from the data is 20 meters. So, in the interval 0 seconds to 2 seconds, the average velocity is given by say 20 meters minus 10 meters, 2 seconds minus 0 seconds, which happens to be 5 meter per second. The average velocity in the interval 0 to 2 seconds happens to be 5 meters per second. Do the process, let us say, for another time interval between 2 seconds to 4 seconds. Let us do that again. Say now t1 happens to be 2 seconds, x1 happens to be 20 meters, t2 happens to be 4 seconds, and x2 happens to be 25 meters. In this interval, V average turns out to be, if you substitute the values, 25 minus 5 is the change in the position coordinate, which we call as the displacement. This delta x is called as displacement, and this is the displacement in the interval 4 seconds to 2 seconds. So, the change in displacement per unit time here happens to be 5 meters per 2 seconds, which happens to be 2.5 meters per second. Change in position coordinate, we are calling it as displacement. So, V average in this case happens to be 2.5 meters per second, whereas in the earlier interval between 0 to 2 seconds, it happened to be 5 meters per second. Let us do this average velocity calculation for another interval of time between say t is equal to 4 seconds, t1 is equal to 4 seconds to t2 equal to 6 seconds. Now, from the data that we have, At time t1 its position coordinate happens to be 25 and x2 happens to be corresponding to 6 seconds happens to be 28. Let us calculate the average velocity in the interval t1 4 seconds and t2 6 seconds, that is the interval between 4 seconds and 6 seconds. The position at t1 is equal to 4 seconds, the position coordinate corresponding to that is 25 meters, and at t is equal to 6 seconds the position coordinate happens to be 28 meters. Now, the V average in this case, if you substitute in the equation x2 minus x1 divided by t2 minus t1, which I am writing it as delta x by delta t, for this happens to be say 28 meters minus 25 meters, which happens to be 3 meters, and the delta t happens to be 2 seconds, the V average happens to be 1.5 meter per second. In all these cases, you realize from the data that we have given you, what we have calculated is that the average velocity goes on changing with time. Let us refer to this position time graph. Let us have a relook at it again. Now, in the interval 0 to 2 seconds, the displacement happens to be 10 meters. In the interval 2 to 4 seconds, it is becoming smaller. In the interval between 4 and 6 seconds, it is still getting smaller. If you want to look at this, how do we look at the slope of the graph? Slope of the graph is the point joining these two, and that is the straight line, and this is delta t and this is delta x. This is delta x and this is delta t, and in the interval 0 to 2 seconds, this is the slope of the line joining these 2 points. In the interval 2 to 4 seconds, let us join this and find the slope again in the interval 2 to 4, that is change in position coordinate by the change in time interval. Again between 4 and 6 seconds, let us do that again in the graph. Look at this. For the same time interval, change in position coordinate is becoming smaller and smaller. It means the slope of the graph is changing. Now, slope of the graph, if you look at this, the line that is joining here, these makes a certain angle, and the slope of this line is delta x by delta t. Now, in this graph, the slope goes on changing, but now look at this, when it goes on after say 6 seconds, between 8 and 10 seconds, 6 to 8 seconds. Now, if you look at the 6 to 8 seconds, the slope is negative. What do you mean by slope is negative? Look at this. Now, x2, this is at time t is equal to 6 seconds, this was the position. At time t is equal to 8 seconds, the position has decreased. Its position has come down, say from a certain level, which is 28, and it has come to 26 or so. In that case, look at this. This was x1, this is x2, x1 is greater than x2. As time goes on increasing, the position goes on decreasing. In that case, delta x by delta t happens to be negative. Means after 6 seconds, the average velocity is negative. What do you mean by negative velocity? In negative average velocity, from 0 to 6 seconds, the velocity, average velocity was positive. That is, till 0 to 6 seconds, the average velocity was changing, but it was remaining positive. But after 6 seconds onwards, till 10 seconds, the slope of the graph is negative, because at the final position coordinate, it is less than the initial position coordinate as time goes on increasing. It only means it was going along the x axis, reached at time t is equal to 6 seconds, it reached the maximum position, then it reverses its direction of motion. When we say the average velocity is negative, it means during that velocity being positive, average velocity being positive, it was moving in one direction. When you say it is negative, it is moving in the opposite direction. Let us summarize what we have learned today. When an object is moving along a straight path in a certain direction, we defined an average velocity, and considering as x increases with time, in that sense the average velocity will be increasing, changing. But when average velocity decreases, it means if it becomes negative, when you say it is negative, it means it is moving in the opposite direction. That is, during that interval the displacement is decreasing. In the next session, we will be talking about the velocity at an instant of time.